Hello, good morning. Good morning to all.
Morning, sir.
Happy New Year.
Morning, sir.
Good morning, sir. Happy New Year.
A very good morning. Happy New Year to all.
Good morning, sir. Happy.
A very good morning, Joshua. Ezekiel, good morning.
Good
Like
morning,
your
sir.
new
Happy
faces.
New Year.
Yeah, Happy New Year. I saw you last year. After 1 year, we are meeting. So it's a good morning to all. So, how was your vacation? It was nice.
Very nice, sir.
Yes.
Very nice. That's great. That's great. That's great. Sam, how was your vacation? Where were you this time?
I was at home only, sir, for New Year's and Christmas from the church. We have some big services, so that we were all preparing for those two services. It was at 5 o'clock
Okay.
mostly.
Okay. Okay. Wow. Ezekiel, how was your vacation?
It was good. After 25th, my PCP classes started. So,
PCP means
personal contact program. So, like the practical classes.
okay in NIOS
Yes, yes.
with the study center or for to other teacher.
With the study center, like I have to go there and
Okay.
yeah.
Wow. Joshua, how was your?
It was good, sir. Had to go to
Huh?
our services. It was good.
It was good. Wow. That's great. That's great. I guess your voice is a bit changed. I don't know. I'm feeling or uh, might be there's some because I'm hearing after 1 year, no, so there might be change. So yeah, how was your Hannah Abigail? Where were you the whole vacation?
I was in my native place.
Okay, that's great. That's great. Wow. I was also there in New Zealand in my bed dreams. Okay, so we'll now leave the vacation time. Now we'll come back to our study time. I hope you enjoyed your vacation and you had a lot of fun. Now come back to studies. We have to complete the course by mid-Feb. Okay, so that quickly we can complete it. Okay, so now today we'll start a new chapter, chapter number 21, surface area and volume. And yeah, by 8, please submit your paper. I guess Ezekiel didn't submit me and Joshua didn't submit me.
So
Rest?
there were questions
Yes.
out of syllabus, sir.
Yeah, I know. Some questions are there, but it's okay. Leave that question and the question which I gave, which is in the course, I'll check that only. Okay. Yeah. So we'll start a new chapter, chapter number 21, which is surface area and volume. So please put a heading in your notes, copy surface area and volume quickly. Okay. Okay. Now we'll start. First topic that we're gonna learn is cuboid. Okay. Who know cuboid? Cuboid, we know everyone. Everyone know cuboids. What are cuboid? Cuboids are the made up of which phases? Hello, Johan.
Good morning,
How are
sir.
you? Good morning. Happy New Year.
Sorry for joining.
Wow.
Had a few some internet issues.
Oh, okay. No problem. Okay. Now we were starting a new chapter. It's a surface area and volume, chapter number 21 in your NIS book, which is coming in your exam. Now, cuboid. Cuboid is made up of which? Cuboid is made up of rectangular faces. Okay. Cuboid is made up of rectangular faces. So how many rectangular faces are there? Can you tell me? Anybody? Can you tell me how many rectangular faces are there? Yes. Yeah,
Six.
you can unmute it and you can say it quickly. Yes, good. Six. So it is made up of six faces. How many corners are there? How many corners are there?
Eight.
Yep, 8 corners. What is the corners? So these are the corners. These are the corners. So you can imagine in your room is in the rectangular form. Okay. So if you will point out each corner, so that it call as corners. Understood? There are basically 8 corners. Okay. How many edges? How many edges are there?
8.
12.
No, no. There are 12 edges. Like one, like this line is one, then two, then three, four, five, 6, 7, 8, 9, 10, 11, 12. Okay, so there are 12 edges are there. Okay, remember this thing. 12 edges are there. Now, what we gonna learn? We will learn first the um, okay. So first we will learn the term of total surface area. First we'll learn lateral surface area. Lateral surface area. Lateral surface area means that area of four walls or rectangular faces. It means that exclude top and bottom. Okay, what does this mean? Now listen, guys. For example, if you will see your front wall, okay, I'll um mm, just give me a second. Okay, so for example, see my camera. This is front wall. Okay, first, second, third, and fourth. So this four area is considered as the lateral surface area. Like you don't have to take the top and you don't have to take the bottom. Top and bottom, if excluded, this is considered as lateral surface area. Okay, what is called as lateral surface area? Did you understand, guys? No.
Sir, is it the side?
Yeah, only sides. Only sides, excluding the top and bottom, is called as the lateral surface area. Okay? Understood, guys? Yes or no? Okay. Now, there is a formula to find the lateral surface area of a wall. So, first of all, we should understand what is this. So, this is called as length, this is called as breadth, and this is called as height. So, now I have this thing. Okay, so this long side is called as length. Okay, this side is called as breadth, and this is called as height. Understood, guys? Can you see that? Okay, I'm repeating again. This is called as length. Okay, this is called as breadth, and this is called as height. Okay, now I told you you don't have to include the top and the bottom part. So you have to take the area of this wall and this wall and this wall and then again this wall. So we'll find it out. Okay, now first of all we have to find the area of this wall. How will you find it? This is length. Okay, I know that it's a rectangular faces. I know it's a rectangular face, is na? So what is the area of rectangle? Area of rectangle is length into breadth. Now in this case, in this wall, this is length. Okay. And what is breadth in this? Height. Like if I want to find the area of this wall, so it is length into height. Yes or no? Can you see that? Are you with me, guys? If you want to find the area of this wall, it is length into height. Okay, so I will write. I will write like this: length into height plus. Now I will turn this. Now in this case, this is breadth and this is height. So if you want to find the area of this wall, so it is breadth into height. So it will become breadth into height. Now I will turn this. Now again, it's length into height. Yeah. So it is length into height. Now if I will turn this, so it is length into height again. Sorry, breadth into height. So it's breadth into height. So the formula is 2 into LH plus BH. And if I will take out the common, so it will become 2H is equals to L plus B. So lateral surface area of cuboid is this thing. This thing. Okay? Did you understand, guys? Did you understand how it came? Yeah, write it down quickly. Quickly write it down.
So that's the answer.
Yeah, that's the answer. That formula, you have to remember it. Remember the formula. Why I'm telling this? Because every question will come from the formula only.
So,
Yes.
what is lateral surface area?
Lateral surface area is basically the area of four walls, excluding top and bottom. Like in your room, there are four walls, na? Your front, your back, your right, your left. That is called as lateral surface area. Lateral means four walls. Understood? Understood? Yes or
So,
no?
if you do this
Yeah.
formula, we'll only get the sides, right? We won't get the top and bottom, right?
Yeah, we will not get the top and bottom. Good. Shall I raise this? Please write it down. Notes should be complete enough. Okay. Now I'm raising this. Now the second point is, after that is total surface area. Total surface area is basically the LSA. Now, what is LSA? Lateral surface area. LSA is nothing else. It's called as LSA. The total surface area is called as TSA, and LSA is called as lateral surface area. So, the lateral surface area plus the area of the top and the area of the bottom. It means that the six faces we have six faces. In the lateral surface area, we are taking only four faces, which are the sides. And in the total surface area, we will take six faces like top and bottom also. So the lateral surface area plus top. So now can you tell me the lateral surface area? We'll calculate again. Now listen, see here. So after that, you please write it down. So first I will write. Okay, now please pay attention. Please see here. Okay. Now can you tell me the area of this face? Anybody unmute quickly? Yes. Area of this wall. This front wall. This is length, and this is height, and this is breadth. Okay. So can you tell me the area of this the front wall? Quickly, quickly.
So length into height.
Very good. LH. Length into height. Now I will rotate this. Tell me this.
Breadth into height.
Yes, breadth into height. Good. Now I load it again. Now this one.
Length into height.
Yes, length into height. And now this one.
Breadth into height.
Yes. Now we have to, like, these are the four walls we completed. Now the top one. This is top one. Okay. Now what is the area of this?
Breadth into length.
Yep, length into breadth or breadth into length. Same. Now the bottom one. Bottom one.
So the bottom one, so will it be breadth, length into breadth, or breadth into?
Yep. Same. Length into breadth or breadth. So, so the formula, like, these are the two times. So I can write 2 LH. These are the two times. So I will write 2 BH. And these are also two times. So I will write 2 LB. And if I will take out 2 as a common, so the formula for that is 2 LH BH LB. This is the formula for TSA of a cuboid. Who clear it down? Understood, everyone? Any problem? No? Good.
So what is that? The second one, the
What?
2 LB, is it 2 LB?
Yeah, 2 LB. First is 2 LH, BH, and then LB. Okay, done? Shall I write this? Is somebody writing? Sam, done? Jehovan, done?
Yes, sir.
Okay. Now we will understand the next formula. So these are the formulas, okay? If they ask you to find the TH, so you have to use this formula to get the answer. Now we will understand volume. So there is simple funda for the volume. Okay, there is a simple funda for the volume. Volume is defined as the capacity of the shape. Like how much water or how much thing is capacity. For example, like this is a bottle. Okay. Now the capacity of this bottle is only 1 liter. So it means that the volume inside the water, if I will fill the water into this water bottle, so how much water will be there? 1 liter. Understood? So in the same way, the capacity of the shape is considered as the volume. Understood, guys? Yes or no? Hmm? Now, now the capacity of the shape is called as volume, and it's always calculated as area of base into height. Remember this thing. Every time. Area of base into height. Whatever the area of base will be there into height, if you will do, you will get the answer as volume. Understood? Now, volume of cuboid. So volume of cuboid. Now what is the now what is the area of base? So this is my rectangular box. What is this is area of base. Now area of base is length into breadth. So length into breadth. And what is height? This is height. So L into B into H is the volume of cuboid. Understood, guys? Yes or no? And the answer will always come in unit cube. Remember this thing. Means, for example, 4 centimeter, 8 centimeter, 9 centimeter, you have to multiply it and then the answer will be coming centimeter cube.
Sir, what is that unit?
Basically, if I will say a cuboid has side of 2 centimeter, 4 centimeter, 2 centimeter. Okay. So for the finding the volume, we have to multiply 2 into 4 into 2 as the formula says. Yeah. So 2 into 2, 4, 4, 16. Now the answer will be 16 centimeter cube because three sides are multiplying, no? So it's become centimeter cube. Now the next is diagonal. Okay, what is diagonal? Okay, what is diagonal? So we'll understand from my room. Okay, okay. Now, for example, this is my room. Okay, it's my storeroom. Don't judge me. Okay. So, for example, this is my room. This is the smallest room which I found. Okay. Now, the diagonal is basically. Can you see that room? Is it clear? No. No. This is good. No, this is clear. Okay. So now this top. Okay, this top of the corner. If I will take a stick and if I will put the top of the corner from this, okay, it's coming, it's coming, it's coming, it's coming to the this. I'm repeating again. I'm repeating again. From this, you can also imagine in your room. Okay. From this top to the this bottom. This is called as diagonal. If I will make a stick here, this is called as diagonal. Understood, guys? Yes or no? So in diagram, if I will make in diagram, if I will make in the diagram, if I will make, so it's gonna be like this. From this to this. This is called as diagonal. This this is called as what? Diagonal. This is called as diagonal. Okay. So the formula for the diagonal is root of L square plus B square plus H square. Root of L square plus B square plus H square. Done? So for the cuboid perspective view, we found all the formulas that are going to be used in this chapter. We find LSA, which is limited surface area. We find TSA, which is total surface area. We find volume, and we find diagonal. Yes, Jehovan.
Sir, since L
Yes, please.
square, I mean, the root of L square plus B square plus H square is L plus B plus H.
No, it won't be L plus B plus H. We can't take out square as a common. It's not in multiply form, no? Okay, so like for example, first we have to do L square. Like for example, 2 is given as L. So 2 square plus B square, which is 4 square, plus H square, which is 2 square. So first we have to do square, we have to add it, then we have to find the root, like this. Okay? Square first, add, and then root, like this. Okay, now we'll do some question based on this. Okay, this is the question. The length, breadth, and height of a cuboid is 4, 3, and 12. The surface area, volume, and the surface area, like we have to find both surface area, the LSA as well as TSA. We have to find. So can you try it? Can you try it, guys? Then I will do on the board. I'll start after 2 minutes. Quickly try it. Done, everyone? Ezekiel, Sam, Jahuan, Abigail, everyone done?
Just kind of find the volume, sir.
Volume. Okay. 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 Now we'll do the cube one. We'll do one more figure today. Second figure is, I guess, cube. Let me check one more time. Hmm. We'll do cube. Now, cube is basically made up of not rectangular pieces, but it is made up of square. And we know that if it is made up of square, then all sides are equal. So cube has 6 square faces. All 12 edges has same length, and it has uh, 8 corners. Okay, so now the length, like in the cuboid, length, breadth, and height is there, na? In this, all three are considered as A because it's a cube, and in cube, all the sides are equal. Yes? Yeah. Now, for example, this is a cube. For example, understand it like this: this is a cube. Now, this is also A, and this is also A. Yep. So, for finding the LSA part, which is lateral surface area. Okay. So this is A, this is A. It become A square. In the same way for 4 walls, LSA is 4 walls, na? This is also A square because this is also A, this is also A. This is also A, and this is also A. It's A square again. And this is also A, and this is also A. So A square. So basically, for finding the LSA of a cube, the answer will be 4A square. Okay. And TSA, the adding of top and bottom. So the TSA of cube is basically 6A square because the top is A square and the bottom is also A square and LSA is 4A square. So it becomes 6A square. Volume, I told you, the area of base. The area of base is A square, and to height. Height is also A. So it becomes A cube. Understood, guys? Yes or no?
Sir, how
And
is it 6A square?
6A square. See, the area of 4 walls is 4A square. Yeah. And the top is A square, which is 5A square. Then the total become 5A square. And the bottom, again A square, it becomes 6A square.
Okay. Top
Okay.
and bottom.
Yeah. And the diagonal. What is diagonal in this? Like from here to here. The diagonal will be root 3A. Or we can write A root 3. A root 3. Quickly write it down. Done? Okay. Okay, so I'll give you some question as a homework. Hannah, please write this homework in the group. Okay. Okay, this is your homework. Okay, this is your homework. Okay, so we'll end maths class here only. Okay, we will have 3 minutes break, then come back in a science class. And today we'll start electricity chapter one more time. Till then, bye Ezekiel, bye Hannah,
Yes, sir. Thank you.
bye. Okay, guys, come back. Come back. We will start our science class. So, um, let me take out the chapter. Everyone, turn on your camera, please. We were doing electricity, but we'll start again that electricity chapter. Yeah. So we'll start because we started. It's like one two topic only we completed, but we'll start it again. Okay. So first of all, take out that chapter number 16. Okay, I'll share it. Hmm. Jashon is there? Yes, Jashon. Good morning.
Good morning, sir.
A very good morning. How are you? How
I'm
was your
doing good.
vacation?
Just okay.
Okay, only okay. Hmm? Bhaiya beat you. That's why it's okay. Okay, so we'll start this chapter, electrical energy. So I think Abigail also didn't date this chapter. Yes, Abigail? Okay, so it's gonna be good. So Abigail, yeah, I want to tell it to you. The chapter which we didn't did with this batch will complete first that, and then we will do the chapter which you didn't do with the new batch, like the light energy we did. I think we did with this batch. So we'll do with the new batch. It's okay. We have time till October, no?
Sir, like I did light energy, but the thing is, I didn't understand everything in it.
Yeah, I will be there. It's okay. First, we'll take a demo class. Then, if you understand, then only we'll take it. Okay. Yeah. So light energy. Now we'll understand light energy. So we have that like we started that chapter. So Sam, what do you mean by light energy? What's the meaning of light energy?
Energy from uh,
Like light energy, not light energy, sorry, electrical energy. Sorry. My bad. What do you mean by electrical
uh,
energy?
um, electrical energy, um, um, electric energy from like electric currents and surges.
Yeah, I mean the bulb is an example of electrical energy. Like you need to switch on the bulb, and then uh, the bulb will start glow. And if you're not switching off, then mama will say shout, "Arey, turn off the light! What are you doing? You are just wasting the electricity. The electricity bill is coming too large." So basically, the light or sorry, electrical energy is the flow of some charges we can say or some electricity we can say, so that the things like tube light, fridge, bulb, cooler, AC, they started working. So they all depends on electrical energy. Now this is electrical energy, but how the electrical energy is formed, what is like from where it came, like what is the formation of that, okay, how it works, what's the principle behind it, we will learn in this chapter. Okay, we know that if you will touch the wire, the naked wire, then you will have a shock and you will have a spike on your head. Okay, we know that. Yes. So how it came, what is the fundamental behind it, we will learn in this chapter. Okay, so first of all, we will learn about the electrostatics. And before starting this chapter, okay, we will understand some of the atom, the we can say the surgery of atom. Okay, so I'll remove this and then I'll share the whiteboard. Okay, now everyone, please see on the board. First, we will learn the structure of atom. Okay, now structure of an atom is first the middle part is called as nucleus. Okay, in an atom, like for example, this is made up of atom. And if you did the third chapter, so in that we will also learn electron, proton, and neutron. Yes, Abigail? Sam? Did you read this? So basically, the middle part has, like for example, this part has proton, which is denoted by proton, and neutron, which is denoted by N. So it means that this is called as basically nucleus, and it is consist of proton, which are positively charged particle, positively charged particle, plus neutron, which is neutral in nature. Neutral in nature means like it doesn't have any charge. Okay, it's neutral. It doesn't have any charge. It's neutral in nature. Okay. And there are some electrons are there. There are some electrons are there that usually revolves around the nucleus, which means proton and neutron. So these green part is called as electrons, and they are basically negatively charged particle. And why I'm teaching this? Because in an object, the object or the any matter is made up of atoms. An atom has proton and neutron and electron. Proton are the positively charged particle that found in the nucleus, and electrons are the negatively charged particle that revolve around the nucleus. Understood, guys? Did you understand? Yes? Did you understand this thing? Yeah. Now, for example, we'll take one example. Now, this this atom has four proton and four electron. So, what is the total charge on this atom? Can anybody unmute and say
Please fill in
this
again.
atom has four proton and four electron. So, what is the total charge on the atom?
4.
Four proton and four electron. What is the total charge on the atom?
Is it 0?
Yes, it's zero. How? Proton is positive, so four positive parts, four negative parts. They will cancel out and make it zero. Understood? Yes or no? Hmm? We'll take case number 2. If this atom has five protons and four electrons, five protons and four electrons, what is the total charge on the atom? Five protons and four electrons.
So will it be 1?
Yeah, which one? Positive one or negative one?
The positive?
Positive one. Yes. So it has positively charged. Positively charged. Okay. Now next question. If it has four proton and five electron, then Sam, what will be the total charge? Four proton,
Say it again, sir. 4 proton.
four proton and five electrons.
What mean negative?
Negative? Negative what?
1.
Yep,
Negative 1.
negative one. Correct. Correct. Negative one. Why negative one? Why
Because
negative one?
they're more negative than positives, sir. More
Yeah.
negative charge.
Yeah. Perfect. 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 Good. Good. You understood. Okay. Now, what does this mean? In an atom, there is always transfer of electron. I'm repeating again. In an atom, there is always transfer of electrons. It means that these electrons which are revolving around the nucleus, they can jump out of the atom. Oh my god. They can jump out of the atom. Now we'll take one example like 4 electrons and 4 protons are there. So what is the charge? What is the total charge? Jeshron, 4 electrons and 4 protons are there. What is total charge?
0.
0. Now I told you this electron can jump out. So it means that now after jumping out, it become 3 electrons. It become 3 electrons. Now what is total charge?
1.
Tell me. +1. Yeah. +1. So now we'll take one more example. These electrons can come from outside also. Like the protons will always stick in the middle, but there is always transfer of electrons from one atom to the another atom. Like we understood, this electron can go outside. In the same way, some electrons can come inside. This is the one case in which 4 electrons and 4 protons are there. One electron jump out. And when one electron jump out, now it becomes 3 electron and 4 proton. Proton is always same. Proton never changes. Okay? Proton always remain in the middle. They never changes. Only electrons can go and come out. Understood, Abigail? Yes? Okay. Now, 4 electron was there. 1 electron jump out. So 3 electron left and 4 proton were already there. So what is total charge? +1 charge is there. Yes, positive +1 positive charge. Now in this case, 1 electron came from outside. So 4 electron is there. No, sorry, 5 electron are there and 4 proton are there. Now what is total charge in this case?
-1.
-1. Yes. Yes. So what was I'm trying to say? Like you when you are rubbing a scale with your head, okay, okay. When you are rubbing a scale with your head, and when you're coming near to the pages got attract. So by rubbing this, you are making them charge. How charging came up? Like for example, this is neutral. When you're rubbing it, there's a transfer of electron, and the transfer of electron are there. Some body become positive and some body become negative. Understood? Yes or no? Yes or no? So, like by rubbing the electron, there is a transfer of electron from one body to another body, makes its charge is called as electrostatic. Like like right now north is very cold. Okay, in the cold, I'm wearing a good jacket, woolen jacket. So when I'm wearing a woolen jacket and I'm running and whatever I'm doing, so because the woolen jacket got rubbed on my body, okay, it got charged. And when I touched the doorknob or the bottle, I got a shock, a great shock. Why? Because I got charged. The electrons, the transfer of electron was there from woolen body to me, making me negative. And when I become negative, I got a shock from a door handle which is neutral. Understood this thing? Did you understand the concept? So basically, the transfer of electrons makes the body charge, and when the charged body comes in the contact with the neutral body, it got shock. Understood? Did you understand the concept behind it? Yes? Sam? Write it down this thing. Quickly write it down. If you want to write. And if you don't want to write, take screenshot. It's not necessary as much as, but if you want to write, it will take time. Otherwise, take screenshot.
Sir,
Yes.
when we touch the doorknob after getting charged, will anything happen to the charge of the doorknob?
Yeah. What will happen? I am get charged. Okay. Like for example, I got negative charge. It means that I have more electrons. Yes, as we learned, if you have negative charge, it means that you have more electrons. And the door knob, which is neutral. Okay. Now what will happen? The electrons will transfer from me, which is more negative, to the door handle, which is less electron. Understood? Yes or no? So that there is a transfer of electrons, and wherever there is a flow of electrons, like here, the electrons are transferring from me to the doorknob. There is a flow of electron, and the flow of electron is basically called as electricity. That's why I'm getting shock.
Okay, so the doorknob will be negatively charged.
No, now the doorknob is connected to the earth. Now the doorknob is connected to the earth. Now the excess electron will go into the earth, making earthing, so that the doorknob will not be get charged. The electrons which extra electron which I have, now the doorknob will transfer it to the earth, so that the excessive electrons will not be there.
Okay, sir, got it.
Okay, shall I use this? Shall I use this, guys? Just give me a second. Okay. So, okay, can you read this, Sam, from here?
Can you zoom in, sir?
Yeah, I'm zooming it. You're using laptop or?
I'm using a laptop, but when I zoom it lags the screen. So it's better.
Okay, let me then make it landscape. Now, can you read this?
That's fine. Yeah, I can read from like
Now, is it okay for you?
yes, it's okay. You must, Shrestha,
Yeah, from this.
you must have observed that a plastic comb, when brought near a piece of paper, does not pick up small pieces of paper. But if you comb your dry hair and bring the comb close to a small piece of paper, you will notice the bits of paper are attracted towards the comb. Do you know why this happens? This happens because the comb gets charged or electrified when you comb your dry hair. The
So
electricity or
now
charge.
only we learned, that how it got charged while rubbing it. There is a transfer of electrons. We got into deep. Yeah, remember this. We got into deep that by rubbing it, there is a transfer of electron. The comb got charged. Now comb is brought near to the this thing paper. It got attract. Okay, understood or not? So we'll take one example from the magnet. Okay, North pole magnet and the another has south pole. So it will attract, the like magnet attract together. Yes, yes. Now, if I will take one example, magnet and iron. Iron is a neutral, no? Iron is not magnetic, but still the magnet will attract to the iron. In the same way, one comb is got charge, but still it will attract to the non-charged paper. Okay, because it has the properties of attraction. We will learn in the next thing, like light charges, like positive and positive charge. Like for example, this is one body and this is another body. Now this is also positive and this is also positive, so they have the same charges. So like charges repel each other. Like charges repel each other. Okay. Now, for example, this is positive charge and this is negative charge. They are the unlike charges. Unlike charges attract each other. Attract each other. And the third example is, for example, this is positive charge or negative charge, any charge, and this is neutral. There doesn't have any charge. Still, it will attract each other. Like, for example, I can take a charged comb and neutral paper. Paper doesn't have any charge. Paper doesn't have any charge. But because the what I'm doing, combing my hair like dry hair, making the comb charge, paper is neutral. It got attract. This is the property of charging. Understood, guys? Yes or no? Now, one more thing. I don't know who is like we are believers, so we never play Instagram. I know, but in the reels or in somewhere we saw that persons are taking blanket and they are taking over one person, okay, and like many times, and then he taking his finger to the gas stove and the gas is on, and when he's bringing his this thing near to the burner, then it got fire. Did you saw that video? Did you saw that video? Okay, let me check it out if I can find it out. Okay, I'll show you one video. Give me a second. Uh-huh. Okay. Can you hear me? Am I audible? I don't know which music is used. That's why I'm not sharing the audio. But let's see this experiment. Okay. What he's doing, the another person is taking the blanket over this person and we'll check what will happen. See? Did you see that? Did you see that? He's saying that invention, it's not invention. It's basically the charge of electricity which is working. Understood? So what he took the blanket over it. Now blanket is rubbing over the body. Now the body got charged, and he put the into the burner. There's a flow of electrons. Flow of electrons gives a shock, and the shock produces the spark, and the spark makes the gas burner burn. So it's not a desi invention. It's basically the science behind it. Understood? Yes or no? Did you understand, guys? Hmm? So this is all about the transfer of electrons. So we'll come back to the chapter. Where is the chapter? Yeah, this is chapter every day chapter 16. Oh, yeah, chapter 16. Yeah. So we were there only. Yeah. So we understood this thing. Okay. So now, yeah, this one experiment is there. So can anybody read this?
For activity 16.2,
Yeah. From here you can. Yeah.
take two straws, a hollow tube through which liquid is sucked, a small piece of paper, a piece of silk cloth, two pieces of threads, 50 centimeter, one small glass bottle, a piece of sellotape, scissors. Take one straw and tie one thread at its center and suspend it from the edge of a table with the help of a piece of sellotape so that it stays horizontal. Let it come to rest. Now bring the other straw nearby the suspended straw and observe the effect. Now rub the suspended straw with a piece of paper and bring the other straw close to one end of the suspended straw. Observe carefully the position of the suspended straw. You will observe that the suspended straw moves toward the straw in your hand. Rub the second straw, which is in your hand, with a piece of paper and bring it close to one end of the suspended straw. Observe carefully the interaction between the straws. The suspended straw moves away, that is, it's repelled. Now take
So
the
now understand it like this. See, the one when you are rubbing the straw with the paper, they are attracting. But when you are moving with the cloth, I think, which cloth is mentioned? Like in the diagram, if you will see that there's some cloth. Okay, so basically, what happened when you're rubbing with the paper? For example, when you're rubbing with the paper, you will see that now they are getting charged. Okay, now they are getting charged, and because of the if they have unlike charge, so they attract. In the first case, we can see that they attract. And the second case, we see that they are repelling each other, like they are moving away from each other. Why? Because they have the light charge. Okay, it's all depend on the what object you are using. So it's all coming 12th class basically. Like for example, if you are taking glass and a silk, like glass rod and a silk, okay, you will find it out that the glass rod is working as a negatively charged body. Okay, but when you are taking a glass and a plastic rod, then you will check that now no sorry, silk and a plastic rod, then the plastic rod is become positive. Okay, so it's all depend on the what object is. We are not going in that direction, but we'll understand it like this. By rubbing it, there's a transfer of electrons, and because of that, there is a charge body we will get. Understood, guys? Yes or no? Anybody has any doubt? Okay. Next, so we can see here there is an attractive force. Why? Because unlike charges are there. Repulsive force. Why? Negative charges there. And repulsive force. Why? Because positive like charges are there. Understood? Yes. So can you read this? Yes, Joshua. Please read this.
We observe, is it the we observe, sir?
Yeah. Perfect.
We observe that the charged straws repel each other, but a charged straw and a glass bottle attract each other. Therefore, it is concluded that two different types of charges, positive and negative, are produced. Charge developed on gas bottle on rubbing it with silk cloth has a different nature than the charge developed on straw rubbed with paper. From the basic uh, from the basic experiment, it is established that the glass on rubbing with silk cloth gets positive charge, which is opposite in nature to the charge acquired by the straw. Like charges repel each other, while unlike charges attract each other.
Yeah. So these are the properties that we have to write it down in your notebook. Okay, about the charges. Like two different charges, positive, negative charges are produced. Charge developed on the glass bottle, rubbing it with the silk cloth has a different nature. So everyone has different nature. Okay, and from basic experiment, it is established that on rubbing the silk cloth with get positive. So basically, I told you the silk with the glass bottle and the silk with the straw. These have different nature depending on the like it's basically called as working potential, but we will not go in that direction. And we should know that like charges repel each other and like charges attract each other. Understood, guys? Yes or no? So we'll stop here only. I hope you enjoyed the class. Till then, bye. Have a nice day. Signing off. Tata, bye bye. Shabakir, sayonara.
Thank you, sir. Bye.
Thank you.
thank